Alright, this is the Unit 2 test review. So here we go. Number 1, which of the following relations is a function? So you're just going to look at your x values, 0, 1, and 2. That's a function. 1, 1, 1. That right there repeats, so it's not a function. 0, 1, 2 is a function. Negative 1, negative 1, negative 1, not a function. Which of the following relations is a function? Would be 1 and 3. Number 2, which of the following relations is not a function? Negative 1, 1, 4, that's a function. Negative 1, 1, 3, that's a function. Negative 1, 4, 5, that's a function. Negative 1, 3, that is not a function, so not a function would be J. Number 3, a function contains the points 6, 6, 8, 12, 12, 4, 15, 8, 22, 3. Write an order pair that would make the relation not a function. All you have to do is just keep the same x value because none of these repeat, 6, 8, 12, 15, 22. So I could just do 8, 10, and that would make it not a function because then you have two 8s, therefore that repeated. Number 4, the relation 7, 4, 8, 5, 8, 16, 9, 16, 13, 12 is not a function. Which x value has more than one y value associated with it? That would be right here at 8. That's the reason why it is not a function. Number 5, which of the following graphs does not represent y as a function of x? Just do your pencil test. It'll be very obvious, like this first one where you cross the graph twice. So A would be which one does not represent. C, you draw your line one time, it only touches one time. B, draw your line, it only touches one time. D, draw your line, it would only touch one time. So the only time that it crosses twice, which is very, 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 very obvious, would be A. Number 6, what's the domain of the following function? So remember, ID the doctor, independent, dependent, domain, and range. Domain is x. So we're going to start over here to the left and then go to the right like you read a book. So on the left side, I'm starting at negative 1, 2, 3, 4, 5, 6 at negative 6. It's an open circle, so less than x. And then go all the way over. It's a closed circle, so it'll be equal to, and just count 1, 2, 3, 4, 5. And there's your domain. Number 7, what is the range of the following graph? This one's discrete because you have points. So if I make an XY table and do my points, I have negative 2.5, negative 1, negative 1.5, 1.5, and I have negative 0.5, that's positive 2, 0.5, 2.5, and then 1.5 and 3. So 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5 points. It wants to know the range. Range is a set of your y values. So you do fancy brackets since it's discrete data, and write your order pairs from least to greatest. Okay, number 8, what's the domain of the function y equals 8 minus 2x? When you put that into your calculator and look at your table, you will get a line that goes on forever and ever in both directions, so your domain is all real numbers, which can be seen as your fancy little r, which can also be negative infinities less than x less than infinity. Okay, number 9. What is the range of the function represented by the table of values below? So again, it's points, so it's discrete data. So you just do your y values here in order from least to greatest. Negative 6, negative 4, 2, and 6. Make sure you're reading, okay? It's asking for range. Range is y. 10, the function y equals 6.240x represents the price y for x gallons of gasoline, which is not a reasonable domain value for this function. Okay, so domain here, we're talking about x. X represents gallons of gasoline. So let's just think about this. Can you buy 0 gallons of gasoline? Yes, you can go to the gas station, go get a bag of chips and not get any gas. Can you buy 2.6 gallons? Yes. Can you buy 4 gallons? Yes. Can you buy negative 2 gallons of gas? No. That doesn't make sense, so J would be the one that is not a reasonable domain. Number 11, what is the range of the function? Range, again, is y. So I'm going to go ahead and graph my equation. Here's x, here's y. Y equals negative 3 would be a line that looks just like this. It's asking for range. Range is my y values. I have no y values up here. The only place, and I have no y values down here. Only place I have y values is right along this line, so my range is y equals negative 3. Now if it asks for domain, domain would be all real numbers because you have every x value on that line. Okay, number 12, what is the range of the function y equals 0.25x minus 2 missing from the table? So all you have to do is go to y equals, type in your 0.025x, and then what you will have minus 2, and then go to your table. And you are looking at when it is, when x is 3, what is your y value? And it would come out to negative 1.25. Okay, 13, what is the range and domain of the function? So again, ID of the doctor, independent, dependent, domain, and range. So let's do domain first, which is my x values. Okay, so x values, you read like a book, left to right. So over here, I'm at negative 2 to open circle, and I'm at 1. So there's my domain. My range, okay, you go from bottom to top. So bottom down here, all the way to the very top. Down here at the bottom at negative 1, 2, 3, 4. See, 1, we gotta get 1, 2, 3 at negative 4. Less than y, less than how far up did I go? 1, 2, 3, 4, 5. And so there's my range. 14, what's the range and the domain of the function in the graph below? So again, domain here is going to be all real numbers, because any x value I think of I can find on the graph. So x equals negative 2, x equals negative 3 would be up here, x equals negative 4, negative 5, and so on. 4 would be there, 5, 6, 7, be off the graph, keeps on going to infinity. My range, though, when I look at my range, the lowest point that I have is here at negative 4. There's no points below that, so y is going to be greater than or equal to negative 4. Okay, 15, what's the domain of y equals 3x plus 1, all that squared? So for this one, your domain will be all real numbers, because when you put that into the calculator, look at your graph, you will notice you have arrows going both to the left and to the right forever, forever, forever. 16, what is the range of domain? So again, let's start with domain. So domain is my x values. Okay, so again, any x value I could think of. Here's negative 1, here's negative 2, here's negative 3, negative 4 would be down here, negative 5, 6, and so on. Same thing, here's 1, here's 2, here's 3, and 4 would be there. So domain is all real numbers. For my range, though, my range, I don't have any y values that go past this little border, and that border would be at 1, 2, 3, 4, 5. So here's 5. I don't have any numbers that go past that 5, so my range is going to be y is less than or equal to 5. Number 17, what's the range of y equals negative 3x squared? Put that in the calculator. You will get a graph that looks like this. Okay, so for my range, that's my y values I'm talking about. Okay, if you look here, I don't have any y values right above that line. Well, that line is at 0, so all of my y values are going to be less than or equal to 0. And it's less than because they're pointing down. Okay, and last one, which of the following functions has a range of y is greater than or equal to negative 4? So here, let's see where I'm starting. I have 1, 2, 3. I'm at positive 4. I don't need to be at positive 4. I need to be at negative. Here, 1, 2, 3. Again, that's positive 4. Here I'm at 1, 2, 3. Here's negative 4. Y is greater than, and that's true. All these values are greater than that negative 4. Here I'm at negative 1, negative 2. That's at negative 2. I need to be at negative 4. So H is my answer here. And that is it for your review.